kinds of memory that we will be looking into, and also what are the basically the things required for control unit design. Okay, so these are the aspects that we will be looking into, but today I will start with memory interfacing. Okay, so what is memory? You already have seen this diagram. Let us revisit this once again. What is the connection between processor and memory? You know that there is you have certain registers in your processor that are used to interface uh, memory. Okay, so one of those register is your memory address register, another is your memory data register. So if you see memory address register, it contains the address, right? And memory data register contains the data. So what the address bus will carry? The address bus will carry the address, and the data bus will carry the data that is to be fetched from that particular memory location. Okay. So you tell me, if you have a 1 kilobyte of memory, okay, how many bits will be required to address the address bus? How many bits will be there in the address bus? Yes, I'm asking you guys. Am I audible?
Yes, ma'am.
Yeah, so who can tell me? Who can tell me this?
Ma'am, 2 to the power 10 byte.
Right, not 2 to the power
Hello?
10 byte. I'm telling you, if you're you are right. If it is 1 kilobyte of memory, if you are having total memory of 1 kilobyte, how many address lines will be required, right? So address bus will have how many lines? So address bus will have 2 to the power 10, that is 2 to the power 10 kilobyte. This is k means 2 to the power 10, these many bytes basically. So there will be 10 lines.
10 line, yes.
Okay, so the address bus will have 10 lines, and the address will be A0 to A9, A0, A1, dot, dot, dot. That means there will be 10 bits. The first address will be
10 bits.
All of you agrees to this?
Yes, ma'am.
Okay.
Yes, ma'am.
So, okay. So, and the data bus is bidirectional. Why? Because sometime you need to get the data from memory to processor, and for writing, you also need to send the data from processor to memory. Because some operation is performed here, and based on that, the MDR will be loaded with that particular data, which needs to be written in that particular memory location. So, the address bus will carry the address, and the data bus will bring forth the data from memory and from processor to memory as well. Apart from these two things, you also know there are some control signals, because this is your memory. You need to tell the memory whether you want to read or you want to write. Okay, that signal also must be passed to the memory module. So these are the following things that is needed between the for the connection between processor and memory. This is clear to one and all. We have been discussing about this for a long time. Now, let us take an example memory module. You see, this is a memory module which has got 2 to the power n addressable memory location. So if it has got 2 to the power n addressable memory location, what should be the size of the address bus? 2 to the power n. So for 1 kilobyte, it could be represented as 2 to the power 10. So what is n here? N is 10. So you need 10 bits of data bus, which will be connected to this module. Okay?
Yes, ma'am.
This is clear to one and all. Apart from this, you also need read-write signal and of course the data bus. Okay. Now tell me, if I tell you your memory is 1K cross 16, can you tell me how many data lines and how many address lines are required? How many bits are required for address bus and how many bits are required for data bus?
Ma'am, 14 হবে? 14.
Why 14? This means 1K cross 16 means 16 is basically the data bus. So there will be 16 lines in the data bus. And 1K memory means 2 to the power 10.
To the power
হ্যাঁ
10.
Okay? So you
আর
need
এটা 2 to
10.
the power 4.
Yeah, so this will be 10 lines here. 10 lines for the address bus and 16 lines for the data bus. These topics are very important from the point of view of your examination. If you are not able to understand something, repeatedly ask, but clarify this today. Okay? Is this example clear? So I'll tell you,
This
you
16
tell me,
part. I thought 2 to the power.
you tell me. Yes, Shani, tell me.
I 2 to the
Hello?
power 10 into 2 to the power 4 is equal to 2 to the
Okay.
power 14. So,
Why 2 to the power 14? From where you got 2 to the power 14? No, but that is not the total memory. When we write 16 cross 8, that means this cross demarks that your memory is having 2 to the power nk locations and each location is having 8 bit. Each location is having 8 bit and so on. So cross this means this is for the data and this is for the address. These many locations and this is the data. That means 2 to the power n location. So for this, can you tell me how many data lines and how many address lines will be required? Shobhi, can you tell me?
Ma'am, 10 address line and 8 data line.
16K. It is 16K.
16 mean,
to the
16
power-
mean 14.
So 2 to the power 14, 2 to the power 4
14,
and 2 to the power 10. So
10.
yes.
this is 2 to the power 14 and this is 8, right? So how many
Yes,
how
ma'am.
many address lines will be required?
14.
14 address lines, right? And how many data lines will be required?
8.
8.
8. Okay? So
Yes, ma'am.
if you are asked some question like this, you have to write it in this way. Is that all right?
Okay. Yes, ma'am.
So for an n bit address line, the maximum number of memory location that can be accessed is 2 to the power n. Agreed? If you have 4 bits, how many address lines you can access? 4 lines are there. So 4 lines will have 2 to the power 4. That means 16 address. 16 address locations will be there. And how many bits do you require to represent it? 4 bits.
4
So the
bits.
address will be A0, A1, A2 and A3.
A2, It's
So 0, 0, 0, 0, 0, 0, 0, 0, 1 and dot 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 1, 1, 1, 1. Orko Jyoti, is this clear to you?
Yes, ma'am.
Perfect. Let's move on. And as I said, M data lines are required for every addressable location. And the read-write control signals are required for reading or writing. But along with that, I've given one more line. What is this? Can anybody tell me? Anybody knows about this signal? This signal is called chip select. Okay. So now let me tell you the concept. When you buy a computer and somebody says that you have a 4 GB of memory, what do you think? Do you think that your entire memory, this is just one module and the entire module will be 4 GB? What do you think? Dipankar?
Yes, ma'am.
Yeah, what do you think?
No, ma'am. The entire module is not 4 GB.
So the total memory is 4 GB, right? When you buy
Yes,
a computer, if your total memory is 4 GB, do you think that one full module you have 4 GB? Or what?
No, ma'am. No, ma'am. No, ma'am. It's divided into several modules.
It
Small,
is
small
divided
modules.
into several modules, right?
Yes, ma'am. Yes,
So
ma'am.
basically, the idea here is that whenever in practice, memory is divided into modules. Those smaller modules, these smaller modules are combined together to form a larger module. Let's say for 4 GB of memory, you might have multiple such modules of smaller memory size, which totally constitute a larger memory block. This is for convenience. This is done. That means this chip select line is required for selecting one of those lines.
Ma'am, could
and
you
we will
repeat
see.
the chip select line part?
Ma'am,
Okay, I'm
repeat this
repeating.
part.
So what I'm trying to say is that when in practice, in your computer, inside your computer, when you say that you have 8 GB of memory, you do not have one single module of 8 GB of memory. Okay, you might have 1 GB module. Okay, 1 GB module you have, and you may require 8 such modules, 8 such gigabyte modules. Okay, to build that entire 8 GB of memory. So your memory is not the total memory doesn't mean that you have one single module. You may have multiple modules. Okay, that makes your whole module. So if your total memory is say 4 GB, and you have one module is 1 GB, then you may require 4 such 1 GB modules. 4 such 1 GB modules, so that your entire 4 GB is built. Okay, so in practice, we do not have a very large memory altogether in a chip. In a chip, we have, let's say, 1 GB, not even gigabyte, we have far lesser than that. Okay, so this is the idea. So the idea is we do not have a very large module, we have smaller modules, and from those smaller modules, we built a large memory. Shani, is it clear? Shankita, is it clear?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Ma'am, the
Now
part
clear.
where you told that CS comes into action.
That is why you need something called chip select along with your other things. Because there are not one chip of this kind. There will be this chip, there will be this chip. There might be somewhere when this chip needs to be selected. one of these chips needs to be selected. So this is selected and this is not selected. If only this is selected, the data from here will be read out. If both are selected, then the data will be read out from this as well as from this. Clear?
Yes, ma'am. Yes, ma'am.
And the data bus is in high impedance state. This I will explain you in greater details, maybe in the next semester. But for now, you understand this is a state which is neither 0 nor 1. Okay, so we will not do anything. So you will not receive any kind of voltage there. Okay, so it is neither 0 nor 1. Fine. That state we call it high impedance state. So basically what it is saying is that the chip select lines CS when active will enable the chip. So 0 means it is active low. That is why see this is bar. When it is 0, then it will be activated. And otherwise the data bus will be in high impedance state. Or in other cases, you do not require anything to be put in the data bus. You do not reading anything from the data bus because this module is not activated. Okay.
Yes, ma'am.
Yeah. So please remember, memory size is specified as 2 to the power n cross m.
Ma'am, here both of them will be in bit or byte.
All are byte oriented. Fine, but
Yes, ma'am. Yes, ma'am.
each one is byte oriented. So I'll give you 1 gigabyte or 1 megabyte like that. That means gig you have to take. Each is byte.
Yes, ma'am. Yes, ma'am.
Yeah. Now we'll
So,
very quickly.
ma'am, sorry for interrupting again.
No problem.
Ma'am, so when we give the memory location part, like 2 to the power n, so
Yeah.
when the n is there, so ma'am, the n is in bits, and but when you give 2 to the power n, that means it turns to bytes. Like we write it in bytes.
You are confusing one thing. You see,
Yes, ma'am.
this is basically, let's say 32 bits are there. Each
Yes,
location is 32 bit. So basically it is 4 byte.
Yes, ma'am.
This is 4 byte.
Yes, ma'am.
Okay. Individual byte has got an address, not bit.
Okay, ma'am. Okay, ma'am.
Okay. But
Yes,
if
ma'am.
you have 4 locations are there. 1, 2, 3, and 4. Okay.
Yes,
4
ma'am. Yes,
locations are there. Tell me how many bits will be required to represent 4 locations.
2 to
0,
the
0
power
will be the
0,
first
0,
location.
0. Yes,
0,
ma'am.
1 will be the 1, 0.
2 to the
So
power.
this is the address. Okay.
Yes, ma'am.
This is the address in bits. But
Uh-huh.
within that address, the first address will be this one.
Yes,
The
ma'am.
second address is this one, and so on and so forth.
Okay, ma'am.
Okay.
Yes, ma'am. Yes, ma'am.
Yeah. Now, basically, your memory system, the memory system that you have in your PC are of 2 types. One is volatile memory, another is non-volatile memory. So what is volatile memory? The word volatile itself signifies that volatile means something which is not persistent, right? So this is a memory system where the stored data is lost when the power is switched off. As long as the power is on, the data will remain. When the power is off, the data will get switched off. Fine. What are the examples? Your example of your volatile memory is cache memory and main memory. So when you purchase a computer, you have seen that one is called RAM. Okay. And cache is also RAM, but this is called cache memory. Okay. Your cache is generally, let's say in KB or like that, or MB, most probably. But your main memory is huge, right? So there are different technologies to build this, but both these technologies are volatile in nature. So when you switch on your PC, these memories get loaded with something. When you execute a program, these memories have certain data. That is why memory is such an important aspect, that whenever you execute a program, your program must be loaded in memory. So if you want to execute a very large program and which cannot be fit in your memory, then we say that we have less memory. So we cannot accommodate to execute a program. And that is why sometimes your execution of program becomes slower. Okay, all those kinds of memories are present there as long as your PC is switched on. The moment you switch off your PC, all the data is gone, right? Again, you have to load that program into memory when you switch on your PC, right? All those kinds of memories are nothing but volatile memory. So the two main volatile memories are static memory and dynamic memory. Fine? Static memory,
Yes, ma'am.
static memory are kind of memory using which cache memory is built. We will look into this in details in next semester course, but for now, you must know that static memories are much more faster, okay, than dynamic memory. And dynamic memory are used to build main memory. Your main memory technology is basically dynamic memory. But this is slower than your cache memory. Slower than cache memory, although their speed is much, much more, but not more than cache memory. Okay, so these are the two different technologies that are used to build volatile memories in your computer system. Is that clear to all of you?
Yes, ma'am.
Any question
Yes,
here?
ma'am.
Okay.
No, ma'am.
Now, what are non-volatile memory? You think of your disk. You have stored something in D drive and your data is permanently stored there as long as you are not deleting it. So even if you switch on or switch off, okay, that data is permanently stored. So a memory system is one where the stored data is retained even when the power is switched off. Those memories are called non-volatile memories. And non-volatile memories are the one which are used in your disk. Okay. So basically, there are various technologies through which you can build non-volatile memories. And one of them is your flash memory technology. You have heard of SSDs. These days, computers or your laptops comes with SSDs. Earlier, it was disk, magnetic disk. Now it also comes with flash memory, SSDs, which are much more costlier. Okay, so these are various different kinds of technologies that over the time has come up where the non-volatile memories are built upon. Okay, so your disk is an example of your non-volatile memory. Even if you switch off your PC, all the data that you have stored earlier will remain. The concept of volatile memory and non-volatile memory is clear to one and all?
Yes, ma'am.
Yes, ma'am.
Okay,
Yes, ma'am.
now let's move on. Under these memories, we have another classification, that is, you have heard of read-only memory and random access memory. Okay, so the random access memory is basically both your static RAM and dynamic RAM comes there. But let us see what is ROM. You think of what happens. Do you know what happens when you switch on your PC? Krishnendu, can you tell?
Post happens, man.
Yes.
Post that check that all of the modules are integrated and working. Then only the computer boots up.
So
Then only the
booting
Windows files
information. Basically, there are certain booting information that when you switch on,
boot manager loads.
yeah, when you switch on the PC, your PC must go somewhere to get those booting information, power on and all those things, right? So that all the other modules which are there get powered and everything. So how does it takes place? Some information must be stored permanently in some location. So for that reason, we
BIOS,
need
ma'am.
certain. Yes,
Isn't it BIOS where the
it's a BIOS
information is?
information. Yeah, this is
Yes.
the BIOS
It's there in the
information.
motherboard. It's
Yeah,
hardwired, right?
it is hardware means it is permanently stored there,
Yes,
right?
permanently.
But then what
And in
memory
BIOS,
technologies will be used?
yes.
So this, for those storing those things, you need read-only memories. We don't write there so much, okay? But we read from there, read data from there. So some information that do not change frequently, like your BIOS information, when you switch on the PC, those information never change. So those informations are basically stored in permanent or semi-permanent places that we call it ROM. So ROM are where permanent data are stored. Permanent data are stored. And these data are written during manufacture in the laboratory. So this is one-time hardware, so nobody can change it. Okay. So this is where read-only memory comes into picture. Your BIOS information, when you switch on your PC, certain informations are stored there. Okay.
But nowadays, ma'am, even you can update your BIOS, right?
Of course, you can update your BIOS. For that reason,
Yes, right
we have
also.
different kinds of ROM. Earlier day when read-only memory came, it is only once written and you cannot change that. You have to replace that. But now there are various kinds of ROM that has come. Programmable read-only memory, which can be programmed again. Another is
Yes, ma'am.
electrically programmable read-only memory. Okay, you can electrically do that using some
Yes.
laser
EEPROM.
point information. And there is electrically programmable read-only memory, EEPROM. Okay, so these are the various kinds of read-only memories that are there in information. So now you have the flexibility, but you and I cannot do it, right? It is up to the manufacturer where they can.
Yes, ma'am, we can do it. Like, we'll have to download that file from their website and do it, right? We
So
just need the
basically
processor
those
to be fixed.
information, those driver information and all those things needs to be there with you. Then only you can do it.
Yeah, yes, ma'am.
I mean, it's something like, as a user, I switch on my PC, I cannot do it. There are some procedure which you need to
Yes, ma'am.
follow to
A
do it.
little bit complicated.
Yeah. So basically, if you ask a naive user, somebody who purchases a computer will not be able to do that, right? But
In fact, if you are updating it and power goes off, then it is gone forever.
yeah,
Like,
those issues are always there, right? Because of the electrical nature of that semiconductor device that has been
yes,
used to build the technology, isn't it?
yes, ma'am.
So these are some of the things that are there in read-only memories. So we will be looking again in details in the next semester course, but for now you understand this. Next is random access memory. I already discussed random access memory. So what is the important point of random access memory? One of the important point is the data access time is same independent of the location. That means if it is a 4 gigabyte of memory, you get the first location or you get the last location, doesn't matter. All will have the same access time, random access memory, independent of the location or the address. So as I told you, these are used in main memory and cache memory system. And static RAM is one that data once written are written as long as the power is on. Okay. Dynamic RAM is also that, but it requires an extra thing. What is that? It requires periodic refreshing when power is on. Again, why that is required? This is again because the structure of SRAM and the structure of DRAM are different. More number of transistors are required to build this SRAM. Less number of transistors are required to build this DRAM. So again, we will be looking into all these details in the next semester course. But for now, you understand that static RAM and dynamic RAM both can store volatile data. Clear? That means as long as
Yes,
the
ma'am.
power is on, you can basically get the data. As long as the power is on. When the power is switched off, you cannot get it. Now see, these are how if you open your motherboard, have you ever tried doing it? Anybody? So that is how you best understand a computer system. You open up your, if you get a junk PC from anywhere, you open it up and see what is there inside. So how a memory chip look like? It is like this. So you see this is your total memory. And you see these are the modules I was talking about. These are the modules. Getting it? So present day VLSI technology allows to pack billions of bits per chip. Per chip, there are billions of bits. And those bits together form a word, and we say that this is one address from where we'll access this word. Okay? A memory modules is used in computers, typically contain several such chips. So we require several such chips to build a larger memory module. Clear, guys? All of you? Shall I move ahead?
Yes, ma'am.
Yes, ma'am.
Now see, I'll show you an organization of an 8x4 memory chip. Okay. 8x4 memory chip. So 8x4 memory chip means there are 8 address lines. So there are not 8 address lines, there are 8 locations.
Locations.
There are 8 locations. And to address those 8 locations, we need 3 address lines. Okay. A0, A1, A2 or A2, A1, A0, whatever you take. Okay. So how it is organized? See this very nicely. In a computer system, how it is required. So for this case, we might not need a 3x8 decoder, but we need this decoder when you see how many address lines you are giving. You are giving 3 address lines, right?
Yes, ma'am.
But it is going to how many lines? How many total number of words? 8x4. Each, how many? So there are 8 such lines. Each line is 4-bit. 1, 2, 3, 4. Right? So there are 8 such words. W0, W1, W2, W3, W4, W5, W6, W7. And each word is 4-bit. All of you agrees to this?
Yes, ma'am.
Now, how many address lines will be required? There are 8 total. Total thing is 8. How many address lines will be required?
3.
3. All of you agree to this? 3. So 2 to the power n equals to 8. So 2 to the power 3 equals to 8. So n equals to 3. Right. So what are those 3 address lines? 3 address line is, let's say, A0, A1 and A2. Okay? You think of what a decoder does. So if you give 0, 0, 0, you want which word to be selected? If you give A0, A1, A2 as 0, 0, 0, the first 0th word will be selected.
Yes, ma'am. Yes, ma'am.
And then you will access this. Okay. If it is 0, 0, 1, then which one will get selected?
The second one.
The second word will get selected.
Yes,
if you give 1, 1, 1, which word will get selected?
The last.
This one will get selected. So, for a 8x4 memory module, okay, this is the schematic diagram of an 8x4 memory module. For an 8x4 memory module, you require a 3x8 decoder. What a decoder will do? When the decoder address is 000, the 0th line will get selected. This will be 1 and all others lines will be 0. Agreed? This is how your decoder works or not?
Yes, ma'am. Yes, ma'am.
Yes,
If the
ma'am.
decoder is
Yes.
00001,
Hmm.
if the decoder line input is 001, sorry, this will be 1 and so on. Okay. So now you have to tell me that if you have a 1K cross 8 memory, what size decoder you will require? Krishnendu, are you there?
Yes, ma'am.
Shobhik, are you there?
Ma'am, 10 cross 8.
Yes, ma'am.
Yeah, tell me this.
Ma'am, 10 cross
Yeah, 10
8.
cross
8.
10 cross
8.
10
10
cross.
cross
Oh, no,
1K
no. 1.
2 to the
10
power 10.
cross. Just do this, guys. Do it simple. Such that you don't have what is 1K? What is 1K? What is 1K?
1024.
2 to the
2 to
power
the
2 to
power
the
10.
power 10.
Okay. So you need a 10 cross 1K. So basically 10 cross 1024 decoder. Agreed or not? There will be 10 lines.
Yes, ma'am. 10 lines.
10 lines and there will be 1024 lines coming out of it. So this will be 10 cross 1024 decoder for a 1K cross 8 and each will be 8-bit. There will be 4 more cells attached to it. Tell me if you don't understand this. Arko Jyoti, have you got this? Tomojit? Shudeep?
Yes, ma'am.
Shudeep?
Yes, ma'am.
Sandeep?
Yes, ma'am.
Everybody is getting this?
Yes, ma'am.
Arunabha?
Yes, ma'am.
Are you getting? Okay.
Yes, ma'am.
Now
Yes,
you
ma'am.
tell me for a 128K cross 16, what do you need? For a 128K cross 16 memory, how much size decoder do you need? What is
Ma'am,
128K?
17
2 to the
cross
power
2 to the power
7.
17.
What
Ma'am,
is K? 2 to the power?
10. Ma'am, I was saying, is it 17 cross 2 to the power 17?
Yes, 17 cross 2 to the power 17. That's it.
Yes, ma'am.
Okay, but see, we never built a decoder such big, isn't it? Do in
Yes,
reality
ma'am.
will make such a big decoder? No. So that is why the memory chips are relatively reasonable in size. So when I was working with chip design earlier in NTU, so we have made until 10 cross 1024, and in real chips you will find up to 9 cross 512. So this is the smallest largest decoder you will find in chips, maybe. Right? And then you can build, larger modules using this. And then you have bit lines, because you might need to read 0, whatever value is here, or write something into it. So the sense or write circuit will either read or it will write the value. So we'll look into all these things later in details. But for now, you understand that for a memory module of 8 cross 4 memory chip, you need 3 address lines. You need a 3 cross 8 decoder. And then you need these many word lines here. These are called word lines. And these many bit lines. And you need read, write, and chip select. So these are what I have told you. 32-bit memory or total memory is 8 cross 4, which is 32-bit. Every row of the memory cell constitute a memory word, and a 3 cross 8 decoder is used to access any one of the 8 rows. The rows of the cells are connected to the word lines, and individual cells are connected to 2 bit lines B dash and B, required for reading and writing. And cells in each column are connected to sense or write circuit by 2 lines. Okay, one is read write, another is chip select. Fine. And this chip select is required to select one chip in a multi-chip memory system. This is all about what I discussed in the previous slide. Now you tell me about 256 cross 16-bit memory. Can you draw the schematic very quickly?
Yes, ma'am.
Yeah, please draw it. So first, someone voluntarily tell me what will be the size of your decoder? What will be the size of your decoder? Quickly, guys.
Ma'am, 2 to the power 18.
Why you are saying that? What made you say that? Can you tell me? So,
Ma'am,
how-
8 into
Ma'am,
2
2 to the power.
ma'am, 18 into 2 to the power 18.
what is 256? What is 256?
2 to the
2 to
power
the power
8.
what? Okay.
8.
So 256 means there will be 256 lines. Okay. You need to have a decoder that will select any one of those 256 lines. Fine. So
Yes,
what
ma'am.
will be the size of your decoder?
2 to the power 18 into 18.
18 in, yes, ma'am. 18 into 2 to the power 18.
This is only
18
256.
into 2 to the power
This is
18.
only-
8 into 2 to the
Sorry,
power
ma'am,
8.
sorry, ma'am. 8 into 2 to the power.
So
I took that as
8 cross 256
Oh,
memory
sorry.
decoder. Is it clear?
Yes, ma'am.
Whatever will be the
Yes, ma'am.
address bit, whatever will be the address line. So 256 lines will anyway be there. Okay. So how will you get 256 line? You have to make 256 in terms of 2 to the power 8. So 2 to the power 8. So 8 cross 256.
256.
Fine. And then you will connect it to 16 lines. Okay. And there will be 16 such. Fine. And each will be connected to the word line W0, W1 up to W255. Okay. And there will be sensor write circuit. There will be bit lines connected to each one of them, and so on and so forth. See this diagram, and you can draw for this one. Clear? Let's move on. Now I'll show you a small example, and then we will continue with the next thing in the next class. How to make larger memory modules from smaller memory modules. Let's say I give you this question. You have to make a 8 cross 8 memory from a 4 cross 8 memory module. How to do it?
Pardon, ma'am?
You have to make a 8 cross 8 memory module from a 4 cross 8 memory module. So your basic module that you have is 4 cross 8. Okay. But your total memory size you need is 8 cross 8. How will you make it? So let us see this. For a 4 cross 8 memory module, this is the schematic. This is 4 cross 8. That means 2 to the power 2 cross 8. So how many bits in the address will be required? 2 bits. So the first address will be 00. The next address is 01. The third address is 10 and next is 11. Each one of these is having 8-bit data. Agreed?
Yes, ma'am.
Now, if you have to make a 8x8 memory module, what you need to do? You just divide with the larger module with the smaller module. Okay? Larger module with the divided by the smaller module. So this is what you have. Okay? If you divide, what do you get? 2 are 8 and 8.
2 cross 1.
You get 2 cross 1.
Was 1. Yes.
That means you need 2 such modules. 2 cross 8 is 2. So you need 2 such modules. But how the modules will be organized? The modules will be organized as there will be 2 rows. So whatever you divide with the address, that will give you the number of rows. And whatever you divide with the column, whatever you get here, you get the number of columns.
Ma'am, I did not get this calculation part.
Okay. So you got this point that you have 4x8 memory?
Yes, ma'am.
But you have to build a 8x8 memory. As I told you, that from smaller memory modules, in practice, the larger memory modules are built. Right? So
Yes, ma'am.
the larger memory module here is 8x8. But your available memory module is 4x8. So what you do, you will divide with 4x8. Okay? And by doing this, what are you getting? If you divide this with this and this with this, 8 divided by 2 is? 8 divided by 4 is?
2 cross, yes, ma'am. 2.
And 8 divided by 8 is 1.
1.
So basically, this will give you the number of rows that will be present with respect to this memory module. And this will give you number of columns. This will give you number of rows and this will give you number of columns. Sankita, is it clear now?
Yes, ma'am.
So basically, again try to understand, we need to build a larger memory. The larger memory here is 8x8. But we do not have a module of 8x8, but we have a module of 4x8. Okay, so using this 4x8 module, how we can build a 8x8 module? So for doing so, the total, what is the total size required divided by the total size available with you? Total module size. You divide, you get something. So here you got 2x1. 2x1 is 2. So 2 such modules will be required, which will be organized in 2 rows and single column. So guys, what I'll do, I'll not extend today's class anymore. You have some other event also. So from here, we can continue in the next class. Right?
Okay, ma'am.
Okay, ma'am.
And all of you, please go through. The Hemacher book is available to you. I told you that is your textbook. Please read from that book. These things are clearly explained there. Okay? And I'll also explain this again in the next class.
Okay.
Any doubt, guys? Very quickly, if you have any doubt, we can discuss, or else we can continue from this point next class.
No, ma'am, it's okay.
Okay.
Yes, ma'am. It is.
Okay. But you have to see it once more to understand
Yes,
it, probably.
ma'am. Attendance.
Yeah. Just